Hello again and welcome. Thanks for joining us on the Space Nuts podcast. This is episode 251. I am your host, or just the idiot at this end of the proceedings. Andrew Dunkley is my name, and joining me is always the expert in everything, the Russ Hinds of astronomy.
The idiot at the other end of the line.
Fred Watson. Hello, Fred.
Thank you, Andrew. Good to see you and hear you again this morning.
Now, I should qualify what I said about Russ Hinds for everybody overseas or who doesn't live in Queensland. But Russ Hinds used to be a state minister in the state of Queensland many years ago, and Russ was referred to as the Minister for Everything because he had so many portfolios. So, yes, I suppose in the United States you'd call him the Secretary of Transport, the Secretary of Communications, the Secretary. He had all these portfolios. So we just referred to him as the Minister for Everything. Quite a character in the history of Australian politics, he was. How are you, Fred?
Very well, thanks. Yeah, all good. Down in
Nice
Canberra
to see
yesterday.
Yeah, would have been cold.
And it was just wet. When I went down on Monday afternoon, I went through horrendous thunderstorms, and it just rained from then. And in fact, our drive back last night was in rain all the way. I might just mention, though, that I was down there. One of the reasons why I was down there was to attend the opening celebration of Questacon's space exhibition, the new Questacon in Space, which is open to the public as of today. Any Australian listeners who happen to be going through Canberra, you can visit this fantastic new exhibition, which is a duplicate of the one that Questacon recently provided for the Australian Space Agency at their headquarters down in Adelaide. So fantastic. Two versions of the same thing.
I plan to see the one in Adelaide.
Yeah, you said
in September. So don't let me forget because I
won't. I'll remind you.
Don't let me. I really want to see that. Yeah.
It's good.
Now, coming up on today's episode, we're going to look at the expansion of testing of Ingenuity because so far so good. 4 tests down and looking fantastic. We're also going to talk about the Quasar satellite. And it's not what you might think by hearing the word quasar. We'll also be discussing false positives when looking at exoplanets and finding oxygen and going, oh, oxygen, there are people, there's life, everything's... Yeah, no, possibly not. And space blobs. Space blobs are probably the most exciting thing we've talked about in a while. Space blobs. They do exist. And questions from Bill in Michigan about the Lorentz-FitzGerald contraction. That's how stars give birth. And Chris in Canberra has some ideas on how Starlink can help in other ways aside from providing the internet. So we'll tackle all of that today on Space Nuts. But first, Fred, yes, as it's been sort of common practice for us the last few weeks, another situation with Ingenuity. 4 tests down, all highly successful. They're starting to think beyond test 5, which is the pizza delivery test, and start to do things that are a little bit more radical, I suppose.
Yeah, this is fantastic news, Andrew. That NASA are so pleased with the performance of the helicopter in its first 4 test flights, and there are images very easy to find on the web of Ingenuity doing its thing, as well as a lovely portrait of the two of them together, a selfie taken by Perseverance, which has Ingenuity on the ground right next to it. Lovely stuff. They're so pleased that they've extended the mission, I think, by another month. That might not be the case, but it's certainly beyond the first. It was all supposed to be over by, effectively, the first week in May. But what is really interesting is that NASA thinks they've identified another landing site for Ingenuity, and it's in an area that's of interest to Perseverance as a place to explore. And so what we might see is Ingenuity heading off and landing in its new site, getting overhead imagery, and Perseverance trundling along to follow it and do the follow-up exploration. I think there are some really interesting rock sites that they've identified, rock strata, exposed rock, which is really what Perseverance is all about. The main mission is to go and climb up onto the Jezero crater delta, but they're in the foothills of that delta now, or the foothills of the deposits that it left behind. So there's probably already stuff that might be interesting. So we're actually seeing... It looks as though we're seeing Ingenuity doing what they said it wouldn't do because it was just a technology demonstrator, but actually doing some scouting for Perseverance.
Yeah, that's great. I think it's, if you've got the opportunity to do it, do it. I mean, if the thing crashes and burns trying to, achieve something extraordinary, that'd be sad, but probably worth the effort. You never know what they might be able to achieve just by extending this operation to a whole new level. I think it's fantastic, and they've done brilliantly so far. I hope the whole thing doesn't sort of fall into the laps of bureaucrats, and Perseverance is trundling along, following Ingenuity, and they go, "Oh, look, there's a fossil. Yeah, we're not going there. Keep going." It won't happen.
Actually, I think they're a bit more pragmatic than that when it comes to space exploration.
Yeah. All right. So we watch with continued interest at the experiences and whatever of the Ingenuity helicopter. Now, let's move on to the next topic, which is that of the Quasar satellite technologies. Which could see a revolution in space communications. This sounds very exciting, Fred.
It is, and the reason why I'm happy to mention this is because it's a great example of the transfer of technology from astronomical projects into the commercial world, and that's one of the things that certainly modern governments are always looking for. They're looking for the spin-offs, they're looking for the feedback into everyday life, and, well, we've seen examples of it already with Wi-Fi, which started its life as a technology developed for radio astronomers. Once again, the radio astronomers have come to the party with this. So Quasar Satellite Technologies, a private company, but it's a spin-off from CSIRO, which is Australia's national science agency. And of course, CSIRO operates things like the CSIRO Astronomy and Space Science, which operates ASCAP, the Australian Square Kilometre Array Pathfinder, along with other organisations. But for their radio telescopes, CSIRO have developed technology called PAFs, phased array feeds, and they are in use on the ASCAP array, the Pathfinder array of dishes, which is in Western Australia. And what they are, Andrew, is it's like a fancy radio speak name for what we would call an image sensor in the world of optical astronomy, the kind of thing that's in your mobile phone but senses images rather than radio waves. So a PAF is an image sensor but for radio frequencies, and they have essentially revolutionized the way radio astronomers work, because traditionally radio telescopes look at one point in the sky. If you want to build up an image, you've got to scan, take your data at many different points, moving the telescope, and then building up the image. But PAFs allow you to, as we do with a camera sensor, they allow you to take the image in one shot. So what's now happened is with Quasar Satellite Technologies, this spin-off company from CSIRO, they've turned things the other way around. They are now proposing to use phased array feeds, these PAFs, but to use them in satellite feed dishes. In other words, the ground stations that talk to satellites, if they're equipped with these phased array feeds, it means one dish on the ground is not just limited to talking to one satellite, it can do it for many simultaneously. Wow. And so you hugely improve the bandwidth of your communications. And it plays directly into the thing that we've talked about before, and we'll talk about again, the mega constellations, which we're now seeing being launched, all these huge numbers of satellites. If you've got several tens of thousands of satellites in orbit, you don't have several tens of thousands of down stations, the dishes that need to talk to the satellites, but the phased array feeds will actually solve that problem. So really interesting technology spin-off there.
Yeah.
Very happy to mention it.
And yeah, it sounds like a fantastic sort of move towards simplifying what was, I suppose, a task that was pretty plodsome. You had to do one thing at a time. Now you'll be able to do multiple things simultaneously, which is always beneficial when it comes to working in space. No doubt about it.
I think
that's great news.
I think plodsome is the word of the day, Andrew. It's a good one.
I'm going for word of the year, but I think Jab will get it. Unfortunately.
Yeah, that's right. Plodsome, that suits me perfectly.
Plodsome, yes. That sounds English. Yeah.
It does.
Now, let us continue on, because we've got another story that's hit the news this week in regard to the search for life on exoplanets, or exo-moons for that matter.
Yeah.
And that is, we may well find planets with oxygen atmospheres and immediately think, oh, you ripper, that's got to be a place where life is, and we shouldn't get too excited about that.
Yeah, that's right. It actually, it plays into a bigger picture question, Andrew, because this whole issue of what constitutes a biomarker, and that's an unequivocal sign of life processes, that pervades the whole of astronomy and space science. There's been huge debates, for example, in relation to perseverance, in terms of what actually is it looking for, what could it find that will be unequivocal evidence of life? And it turns out there aren't many things. There's one or two things that are very pointed towards life, and in fact one of the ones I love is things called Mickey Mouse ears stromatolites, which are rock formations with Mickey Mouse ears. They look exactly like it. The strata are bent up like this. I've drawn a picture of them for my new book, in the children's book, as you would with a name like that. But they might be, they're thought to be something that will be very difficult to explain without biological processes. So the same sort of thing happens when we talk about exoplanets, which before very long we'll have the capability to image directly and look at the signatures of gases in atmospheres. And we've talked for a long, long time about the possibility of biomarkers turning up in those atmospheres, and indeed possibly technomarkers, or technosignatures they're sometimes called, excuse me, which will be something like chlorofluorocarbons in the atmosphere of an exoplanet that only come from industrial processes. So you're absolutely right. Oxygen, we believe, on our planet has mostly originated because of bacterial emissions. Excuse me, several billion years ago. I think it was about 2 billion years ago that the oxygenation started. I can't remember the numbers, but we think that most of the oxygen is from plant life, effectively, and so that's a nice step to say, well, if you find oxygen in the atmosphere of a rocky exoplanet like ours, is it a guarantee of there being life there? And that's what this new research is about, because the answer is no. There are several, alternatives. This is some work that comes from University of California, Santa Cruz, where they have identified at least 3 other mechanisms that could cause an atmosphere to be oxygenated without the need for life processes. So the bottom line is that oxygen is not enough. And once again, astrobiologists have been talking about this kind of thing for a while. What you really need to look for is oxygen which is out of equilibrium with some other gas, for example methane or carbon dioxide. You're going to be not just looking, waving the flag, yay, we found oxygen, we've discovered life, but you will have to find other gases that complement it, and together which are much stronger evidence of life processes.
The other telltale sign of life in other planets is approaching intergalactic ballistic missiles. That would be
Well, nature throws those at us as well, actually. So
that's
even
true.
That would be. They're called asteroids.
Yes, very, very true indeed.
Yeah.
So when it comes to identifying these markers, we're going to have to double check, because it won't absolutely mean that there is probably life there. Although, as you and I have discussed many times, the probability is we will find it. There will be places that have microbial life or something. I imagine, I'll take another giant leap and say, I imagine there's probably planets out there that have a primordial soup and perhaps have reached the algal stage of evolution. I would like to think that. I know a lot of people believe that there are probably planets with civilizations that are nearly as advanced or more advanced than us, but we would never find them. That's the saddest part of the whole story. Even if they do exist, and there's so much to say probably not, we will never know about them unless we or they come up with some incredible technology through particle physics to bend space and time and just sort of do a giant leap from one part of the universe to the other and say, oh, g'day, how you going? Look, can you tell me how to get to the petrol station? Or something like that.
So I, to qualify that, it is certainly possible that we might know about them because of technomarkers or biomarkers. There will be ways, like the discovery of CFCs in an atmosphere, or like
of course.
the sensing of radar signals or something like that. But you're absolutely right. The chances of us being able to walk up there and knock on the front door, just because of the distances involved, that is a much smaller prospect, and that might be a good thing. If we look like tasty morsels to some of these advanced civilizations.
Well, look at it from another perspective, Fred. We have a history of hostility. We are not nice people.
No,
I don't think I'd want to be a part of a civilization where we turned up, because we know what we're like. There's always that issue that confronts us as human beings. Our nature is not always well-meaning, if I can put it that way. Would that be a fair assumption?
Yeah, I'd qualify that. There's a new book just out by somebody who specialises in this kind of thing. I was listening to a review of it when I was driving down to Canberra, which talks about there is an underlying niceness about humankind, although we are competitive as well, and evolution's driven us that way. The survival of the fittest, the ones who can beat up their enemies the best are the ones who survive. And they write the history books too, as we well know.
Yeah, that's probably true. Yeah, and I suppose our early escapades into another world would be, we come in peace, because we wouldn't be sending military people straight in. But
you would hope not. No, you would hope not.
But science fiction always looks at the dark side of things, so that's probably where my brain is. But
I should just mention, talking of such things, that I said that the Questacon Space Exhibition opened yesterday, and yesterday, of course, was May the 4th. And that was why. So there was a very strong Star Wars theme, and I got to stand next to Princess Leila's sculpture. You're familiar with that, but it's a rather spectacular abstract sculpture, basically looking like a string of DNA. I've got a picture of me standing right beside it.
Nice.
Which is on my Twitter feed, by the way.
Oh, wonderful. There you go.
Yep.
We're going to take a little break, but when we come back, we'll be talking more about some strange things in our universe here on the Space Nuts podcast with Andrew Dunkley and Fred Watson.
Space Nuts. You've been listening to the Space Nuts podcast.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.